Hello! I've been doing some more work on my 3-bit wide memory space, which is what the 3-bit to 8-bit bus transceiver matrix was about. So this can take a 3-bit word and map those bits onto 3 8-bit words. But those 8-bit words need to be stored somewhere, right? So that's the bit that I've been working on. Confusingly enough, though, there actually needs to be a bit in between them. So this will take a 3-bit word and map it onto 3 8-bit words, as I say. This will store 3 8-bit words. Okay, fine. But the trouble is, with the way this does it, the one bit that we want will be that we want to set will be asserted one way or the other. It'll either be driven high or driven low. The other 7 bits will be left in an indeterminate state, and that's no good for this, because where we essentially only want to update 1 bit at a time, we want the other 7 bits not to be floating or indeterminate, but to be whatever's already there. So we're going to need a muxer in between the two. So there'll be 2 8-bit words. There'll be an 8-bit word which will be 7 floatings and 1 asserted. And then there'll be an 8-bit word which is 8 asserted bits, either high or low. And then the muxer needs to say, okay, we want to take this bit out from this word, and all of the rest will come from this word, and produce a third 8-bit word, which is what actually gets stored. Now, that is complicated by the fact that these SRAMs have bidirectional data pins. They have I/O pins. They don't have inputs and outputs. So you can't do a kind of feedback. You couldn't connect this directly to the muxer and say what it's outputting is on one side, what's coming from the mapper, the matrix, is on the other side, and then just mux them, because its data pins can only either be input or output. It can't input and output at the same time. So that's what these are for. These are, what are they? 74HC 574 8-bit register chips, essentially. I'm not sure what the datasheet would call it, probably an octal latch or something like that. These are the ones with the tri-state outputs as opposed to the reset signal. And the only reason I've gone with the ones with the tri-state output, even though we don't actually need to control whether or not it's on or off, which is why the output is just wired straight to low, though I've evidently not done the other 2 yet. The reason I chose these chips over the ones that have the reset pin here instead of tri-state buffers, outputs, is that these ones have all of the inputs on one side and all of the outputs on the other side, so a byte just flows straight through it. Whereas the other variety, such as the ones that were used on the register module, these ones, they instead go output, input, input, output, output, input, input, output. So 4 of the bits are on the upper side and 4 of the bits are on the lower side. And sometimes that's useful, say in the case of the register module, where I'm then also using the 74244 buffers, which also have the same deal. 4 of the inputs are on one side and 4 of the inputs are on the other side. So for this, it works out. It's ideal. But here, it makes things quite complicated. So I've just decided, sod it, let's just use the ones with the inputs and outputs all on the same sides, and just tie their output enables low, and there you go, that's fine. Does it actually matter if there's a capability to reset? No, I don't think it really does. I could be proved wrong. Let's wait and see. Now, I haven't actually tested any of this or powered it yet. I hope it works, but we'll see, because I've literally just finished putting in these last wires. So what we have here are 3 register buffers. Well, I'm calling them buffers, or sort of temporary variables, essentially, that we can copy it into so that these can stay outputting while these are inputting. But they're not buffers, but for some reason I keep referring to them as buffers. We've got the 3 SRAM chips that we're actually going to store the data in. And then we've got another 2 register chips, the same variety again, the 74HC574s. And these are essentially the memory address register. The reason that they're so far apart was because I did have it in mind to put a big old bank of these LEDs in between them to show the current address being addressed, addressing addresses. But I'm starting to wonder if I'm even going to be able to fit that in, because the wiring density here is just so great that, I've only got 1 row left here, and I had to really put in some effort and shove these things around in order to be able to keep that free, which is great because it means that I could grab my little cable and just go, there you go, and feed straight into it. And I think that's a really advantageous thing to have. But if I can do that, then I've used up all. I need to leave these free so I don't have space to put the LEDs in. I don't know. I'll decide. I'll figure something out. Maybe I'll just make a couple of really short leads like this that can be just sort of jumped like that. It would be slightly less tidy, maybe, but I don't know. I need more LEDs. It needs more flashing lights, because this module doesn't have any. This module doesn't have any, and yeah, it's oh dear, shit. Sorry, I've just knocked my microphone stand, and it's starting to get a little bit, lacking in flashing lights, which is important to me. So yeah, I did experiment with a couple of different layouts, because originally I had the idea of saying, okay, well, in here, this handles 1 bit of the 3-bit word, this handles another bit, this handles another bit. So thought about just continuing it along horizontally and essentially having, there you go, there's the memory chip for that bit, there's the one for that bit, there's the one for that bit, and then putting the registers in and all that kind of stuff. But I found that, I don't know, I just, this layout kind of came to me, and I did these, and I thought, oh, that seems quite nice and tidy. And I've managed to put in all the address wires, so I'm probably going to go with this at this point. There was a point I was going to make about that. Oh yes, I remember what it was. That is that. So I was okay. Why was I thinking of perhaps doing them vertically like this? Partially because then you keep 1 bit across 1 row, and I still think that's a very sort of useful visual thing that I lose with that layout. But also because of the sheer wiring density doing the addresses, it's quite beneficial in those cases to parallel them all up and then just jump from one chip to the next. Give me 1 sec, let me see if I can grab the old 16-byte memory module and you can see what I mean by that. Oh no, that's the ALU. It's in one of these boxes. Is it this one? Nope, it's not that one. Okay, it's unreachable at the moment, but you can kind of see it in this. So we've only got the 2 rows, and let me just adjust the focus for you. There we go. And you can see how they just kind of jump over fairly straight, and you can parallel them up quite easily, and they just about get squeezed past each other. So I was considering doing that for the addresses, but then if I put these intermediary registers at the same level as these SRAMs, it then means that all of these have to go like that, and that squeezes a lot of wiring into a small space and then becomes quite untidy again. So I don't know. So I thought, well, maybe you could do a kind of halfway house type thing, parallel all these up and then bring them up like that, the 8-bit parallel buses, because that would still keep these relatively tidy, though it does mean, you know, doing these angles is a bit of a challenge sometimes if you want to get them nice and tight with each other. But I can just about fit all this like that, so I've gone with this for now. I think at this rate I'm probably going to stick with this one, but we'll see. Maybe if you've got any ideas or suggestions, please let me know. Now, one sacrifice that I did have to make in order to make all of this addressing fit in here is that the bits, the designated bits here, do not line up with the designated bits on the chip. So what do I mean by that? Let me grab a pokey. So I believe, if I recall correctly, that on the datasheet this is A0. This is the least significant bit in the address, and this is the most significant. So they kind of wrap around like that. So what it means is that this is, what is it? That would be 0, 0, 7. So that would be bit 8 of the address, assuming 0 indexed, or bit 9, assuming 1 indexed. I don't know. What's convention on that? Again, let me know. Let's say that this is bit 9, and it's being mapped to what the SRAM thinks is bit 13, or something like that. So essentially, the addresses are all kind of jumbled up within here, within this bit. And they were literally just wired in the way that keeps them the most compact and keeps them straight, because then you can pack these all up quite close to each other and manage to get it all in. If I'd have actually tried to maintain bit 0 on what this chip thinks is bit 0 goes to what this chip thinks is bit 0, then there's going to be lots and lots of crossing, and it's going to get very, very nasty and untidy very quickly. So I thought, sod it, all of the addresses are still going to be unique anyway, and besides, the address that you give this chip, that then gets converted into columns and rows and stuff internally, so it doesn't really matter. It's just at the interface points that I want to make sure that I keep the convention of least significant bit, most significant bit. So that's the case for these 2 address bytes. That's also the case for all of these data bytes. It's just not the case within the addressing here, but you can't win it all, I'm afraid. So yeah, We'll see if I can find a way to squeeze in an LED display of the address, because I do really think that that would be a good thing to have. And I then need to get onto Farnell and order more of these quad tri-state buffer chips in order to build a muxer, which is then going to go in between. So what happens at the moment, do I have a pen to hand? Yes, I do. What happens at the moment is that we'll get a 3-bit word, and that will be mapped to 3 8-bit words. And what that will essentially look like, say we're mapping it to 0, 1, 0, so 0, 1, 2, so yeah, the third position, is that we'll end up with 3 8-bit words that look like this, essentially. So that's the most significant, 4 and then 4. So it would be something like disconnected or high impedance. I suppose that would be Z, but fuck it, I'll just put an X. And then 1, and then 2, and then 1, 1, like that. So all of these bits are actually floating. Right? So that bit got put into there, that bit got put into there, and that bit got put into there, and this decided which of these positions it was going to go into, right? Now, for reading, that's fine, because we really don't care what all of these are. We truly don't. But for writing, that's a problem, because these SRAMs need to write a whole byte every time. So if we were to just hook this straight up to this and say, there you go, go write, every time we wrote one of these 3-bit words, the only thing we'd be guaranteed is that within the byte that it's stored in, only, that position bit is set the way we want it. These may be, these may not. They're floating. Who knows what state these are going to be in. So that's no good. So what we'll need is a muxer that can say, okay, this is what I'm receiving, and what I've already got in the memory is, let's say, 1, 1, 0, 0, 1, 1, 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 1, 1, 0, 0, 1, 1. So this is the mapped value, and this is what's stored. Now this is where it turns out that my example here doesn't actually... Okay, my example would change this one. Okay, so what we need is a muxer that would say, take this value and say, this is the bit that we're changing, and I'll probably put that arrow in a dodgy place, but okay. And what it's going to do is say, take this as the default, and then just mux that into it. So for the first least significant bit, it's, we're not looking at that one, so we can just copy that straight in. So that's 0, 0, 1. Again, okay, that's fine, so that's 0, 1, 1. The third column, that's the one that we want to bring in from over here instead. So we'll bring that from there, 0, 1, what am I talking about? 1, 0, 1. And we can see that that's a departure from what's here, because this is 1, 1, 0. That's... And then the rest will all come from that side, right? And then this is then what we want to store in these SRAMs. So this board is essentially this bit here. This board is essentially this bit here. And I have yet to build the Muxer. I may be able to build that with the chips that I have. I don't know. I can have a look. With just some like ands and ors and logic like that. But for some reason, my head wants to do it with buffers. I'm not sure. Is there a name for that when you're constructing, when you've got a circuit that you could implement with logic gates or with combinations of buffers? Is there a name for those two different approaches, or am I just talking crap? I'm probably just talking crap, but hey ho, it wouldn't be the first time. Anywho, I've probably gone on long enough for this one, so I'll keep having a fiddle with this, and at some point we shall run some tests and see if it's doing what I think it's doing. And then the next step would be to build the Muxer and then find a way to hook it all together. I may need to get a sheet of perspex or acrylic or whatever plastic that is in order to stick all these down and keep them together, because unfortunately breadboards don't lock together this way. And personally, I find it quite frustrating, the way that breadboards are laid out, the fact that they would connect that way but not that way, and the fact that they don't seem to have good ratios that mean that you could, you know, arrange them like that. I don't know. I sometimes think that maybe I should look into to develop a better kind of breadboard like that, but I suspect I would perhaps be one of the very few people who'd actually buy them. So, yeah, c'est la vie. Anyway, I hope you got whatever it is you get out of these videos. Please do let me know what you get out of them. I'd be fascinated to know. Do you just like seeing the wiring porn? Are you looking to learn to build your own, or do you just want to see me fail? Because that's cool too. I've not been publishing those videos, but if that's what you want to see, then we give the people what they want, don't we? So yeah, have a good one. If you liked it, please do like it. It gives me warm and fuzzies. I am continuing to post videos like this, so if you'd like to follow along with the project, do hit subscribe, but it's entirely up to you. I'm still not... I think I'm still refusing to acknowledge the fact that I'm actually making YouTube videos, and I don't really like to do the whole, please like, share, subscribe, and... it's like all of the advice is like, oh, you really need to tailor your thumbnails and put text on them and arrows and things. It's like, oh, I don't really want to do that. I'm just me. I'm just building a thing. That's why I say, let me know what it is you get out of these videos. I'd be very interested to know. So, yeah. Have a good one. Bye.